Hello, everybody. So our area of interest is about the rate of force development, commonly called RFD. But what we mean with this term? The RFD is an expression of quickness of contraction and quantifies a muscle contraction explosiveness. Actually, we know the neural and muscular determinants that compose the purely explosive contraction, and we know also that the RFD is a valid indicator of neuromuscular fatigue compared to the classical maximal force that a subject is able to produce. For these reasons, for this reason, we were interested to understand the asymmetries in biceps and triceps in both limbs through a series of purely explosive contraction at submaximal level and through the maximal force for each muscle because they play a critical role in everyday living and sport contexts in non-disabled, amputee, and wheelchair users. But first of all, I asked you, what is your strongest arm? Remember your answer, and I will discuss about it at the end of this presentation. So we had three aims. First, to examine if dominance affected muscle function. Second, we investigated if muscle function asymmetries are muscle-specific or, conversely, if one side is overall more performative than the other independently of the muscle group. Third, we investigated if within each muscle group, asymmetry's direction is consistent among various muscle performance metrics. So, what we have done, our subjects were seated with their arms tied in a special measurement device for the force signals, and they performed two maximal voluntary contractions, both in push and consequently in pull, and 12 purely explosive contraction for each of the four different levels of submaximal force, in detail at 80, 60, 40, and 20% of their maximal force. So, what were our main results? At the individual level, the asymmetries are muscle-specific and rarely favor the same limb across different muscle groups. You can better understand this result by looking at the first picture. The first is shown that the mean of every metrics adopted through all subject is in average close to zero, and that means that when adopting various performance metrics, there is no one limb more performative than the other in general. Each limb is favored depending on muscle group and performance metrics, independent of dominance. You can see the same in the second image that show an example of a subject through the different metrics analyzed. If the bar go up, the metric is in favor of dominant arm. Vice versa, if the bar goes down, is in favor of non-dominant. From a practical point of view, the present findings suggest that to determine the strength asymmetries, practitioners should adopt that specific test for each relevant muscle group. Even more importantly, the current study may inform the practitioners when they try to treat strength asymmetries, for example, when they prescribe physical training to diminish the asymmetries level of a person. The strength asymmetry should not be treated just by performing more exercise on one side, for example, the weakest limb, compared to the other, the strongest limb. Each side may need more specific training for the physical characteristics where it is less proficient. For example, one side may need more maximal strength training, while the contralateral side may need more explosive training. To conclude, if someone will ask to you, what is your strongest arm? The answer is, depending on the metrics of your interest. Maximal force, explosiveness, depends. Thank you.